Let's review for chapter 7. So first, let's go ahead and review the graphing. For cosine graph, so over here, the A will give you the length of each petal. So 4, the petal would be 4. And over here, the B is 1, so you're going to get 1 petal. And for cosine, you always start at the 0 degree. It has no rotation. And then when you go to 4 cosine 2 theta, when the B is even, you're going to double the number of petals. So when the B equal to 2, you get 4 petals. Again, 4, you get length of 4. And for cosine, it begins at 0. And since there are 4 petals, it will spread out evenly. So 360 degrees divided by 4, you get 90 degrees. So each petal would be 40 degrees apart. Again, all the petals will spread out evenly. Now, when you go to 4 cosine 3 theta, again, the length is 4, and cosine always starts at 0, and B is 3, so there are 3 petals, and 360 degrees divided by 3 give you 120 degrees. So each petal would be 120 degrees apart. Okay. Now, for the sine graph, would be the same way, except for the sine graph, there would be a rotation. And rotation would be 90 degrees divided by B. So in this case, 90 divided by 1. So rotation is 90 degrees. So it starts at 90 degrees. Okay, so see the comparison. Okay, now when you go to 4 sine 2 theta, and again, so the B is 2. So there will be 4 petals. And this is sine, so there will be a rotation. So 90 degrees divided by 2 will give you 45 degrees. So rotation would be 45 degrees. So it starts at 45 degrees. And there are 4 petals, and so each one would be 90 degrees apart. So it would be all 90 degrees apart. Then when you go to next one, 4 sine 3 theta. So again, the length would be 4, and there will be 3 petals, and it will be 120 degrees apart. Because this is a sine function, so there will be a rotation, and the amount of rotation would be 90 divided by 3, give you 30 degrees. So you start at 30 degrees. And they are 120 degrees apart. So 30, you add 120, you get 150. And next one, you add another 120, you get 270. And so this is a graph for this type of graphing. Now let's go to the next type. So this one is the one with K. The one with K, all you have to do is just go and get the critical value for 0, 90, 180, and 270 degrees and plot those 4 points. Okay, now when K is bigger than the A, the R will always positive, so you can see that it radiates out from the origin. See, it's positive in all directions. Now when they are exactly the same, sometimes this part will be negative and they will become exactly opposite, so it becomes 0. So at 180 degrees, you get exactly 0 over here. Okay. Now when K is smaller than A, sometimes the R it becomes negative, like when it's 180 degrees. So there's an inner loop when the K is smaller. Okay. And so again, and same thing with the sine. And notice again, there's a rotation, but to figure out the rotation, it's easier just go and plot those 4 points. Just figure out the 0 degree, 90 degree, 180, and 270, and plot those 4 points, connect the dots to get a graph. Okay, so again, same thing over here. You just get the value for 0 degree, get the 90 degrees, get the 180 degrees, and get the 270, and you plot those 4 points. And over here, when you get over here, there's a negative value, so it get flipped to the inside. So again, when K is smaller, there's an inner loop. So you get the value for 0 degree, 90 degree, 180, and 270, it get flipped to the inside. And so go ahead and be familiar with the graphing. Okay. Now next, let's go to page 407, and let's go and do some of the problems. So page 407, and let's start with number 20. For number 20, you have 4, negative 5 pi over 6. And instruction says you want to change to exact rectangular coordinates. Okay. So this is the polar coordinate, so this is r, this is theta, and you want to convert to rectangular coordinate. So what you want to do is go and draw go and plot this. So it's negative 5 pi over 6 is right over here. So negative 5 pi over 6. and the radius is 4. So this would be negative 2 square root of 3. So by looking at this picture, use these two, you can figure out the rectangular coordinates. So the x would be negative 2 square root of 3, and the y would be negative 2. Okay. So this would be your rectangular coordinates. Now let's go to 26. 26 is the other way around. You want to convert the rectangular coordinates into polar coordinates, and you have to watch the boundary. Okay. So over here, they want you to make sure that r is greater than 0, so that because without the limits, there would be infinite number of possible solutions. So they put in a boundary, so they limit down to a particular answer. So you can sketch it out. So negative square root of 5, negative square root of 5, negative square root of 5. And so this is a 45 special triangle. So the hypotenuse would be square root of 2 times that. So it would be square root of 10. And from here, notice that if you go this way, it will become extinct. So if you go this way, it will go over the pi. So you cannot do that. So you have to go this direction. Okay. Again, you only can go up to pi. So you can go up to here only. So you cannot go this direction to get here. So you have to go this direction. So the polar coordinate would be, the radius would be square root of 10, and the angle would be negative 3 pi over 4. So you have to go this direction. Next, let's go to number 42. Let's go to 408, number 42. This one, you want to convert the rectangular form to polar form. So you got y squared equal to 5y minus x squared. So you need to use a relationship y equal to r sine theta and x equal to r cosine theta. Use this relationship to substitute in here. So you're going to get r sine theta squared. Again, when you substitute, put in parentheses, and then just do substitution. Don't do simplify, or else it's very easy to make careless mistakes. So y is r sine theta minus x squared, so it'd be r cosine theta squared. Now next, you go and multiply everything out, so you get r squared sine squared theta equal to 5r sine theta minus r squared cosine squared theta. Now in this case, you can go and divide by r. Technically, you shouldn't do that, but you can divide by r and set r equal to 0 to recover the answer. But since r equal to 0, so that's going to divide by r. But because when you divide by variable, you're going to lose the answer. So you need to recover the answer by setting equal to 0. But r equal to 0 is a dot, and a dot will include in the solution already. So the r equal to 0 included in one of the solution, right? So you don't have to worry about that. So from here, you can go ahead and get the r to one side. So you get r sine squared theta plus r cosine squared theta equal to 5 sine theta. And you can go and factor the r. And sine squared plus cosine squared equal to 1, so you got r equal to 5 sine theta. Okay. Now there's a faster way to do this if you recognize the x squared plus y squared. So in other words, another method, the quick way of doing this kind of problem is move the x squared to this side already. And recognize that using the Pythagorean theorem, x squared plus y squared equal to r squared. So this is equal to r squared already. And this is equal to 5r sine theta. Okay, again, x squared, use the Pythagorean theorem, x squared plus y squared equal to r squared. And from here you can divide by r. So r equal to 5 sine theta. So this is a quick way if you recognize that. But if you don't, just substitute and work it out. Okay. Okay, let's go to number 52. You have r 3 cosine theta minus 4 sine theta equal to -1. So in this case, what you can do is you can go and distribute, because you need to have r to convert. So distribute. So you want to convert to rectangular form. So distribute, you get 3r cosine theta minus 4r sine theta equal to -1. And r cosine theta equal to x, so this is 3x. And r sine theta is y, so minus 4y equal to -1, and that's it. Okay, let's go to page 428 next. On page 28, let's go and do 10a. You have negative square root of 3i, and this one you want to convert to Porter form. So what you want to do is go and sketch it out. So negative square root of 3i is right over here. So negative square root of 3i. So by looking at this picture, you have to use the Porter form. So Porter form, the angle, again, you have to watch the boundary. Okay, the boundary is negative pi and pi. So you cannot go this way to get 3 pi over 2. You have to go this way. So angle would be negative. So the radius would be square root of 3, and the angle, because radius is always positive, right? So and the angle would be negative pi over 2. Okay. And let's go to 12a. 12a, you have square root of 3 plus I. So sketch it out. So square root of 3i. So square root of 3. So this is 1i, so it's 1. Again, I is just a direction. So from here, you're going to get 2. So in this case, you get the, okay, back up. This one you have to put, this is the coordinate. They want you to put it in Porter form. So you have to do square root of 3 e to the negative pi over 2i. Yeah, back up on that. So you have to watch if they want you to convert to coordinates or the form. Okay, so this is coordinates. So they want you to convert this into the form, the Porter form. So this would be the r and the angle. Okay. So same thing. This one over here. Let's back up a little bit. So pay attention to what they ask you to do. Okay. So again, this is a coordinate. This is a form. So you got to know the difference between the two. So this one, the radius would be 2. And the angle would be 30 degrees or pi, the 30 degrees of pi over 6. So it would be pi over 6i. Okay, let's go to 14. 14 is backward. So you want to go from Porter form to rectangular form. So you got 2e pi over 3i. So sketch it out. So pi over 3 is up here, and the radius is 2. So this is 1 and square root of 3. So your rectangular form would be 1 plus square root of 3i. Okay. And let's go to 16a. 16a, you have 6 e to the pi over 6i. So you can go and sketch it out. So the radius is 6 and angle is pi over 6. So this would be 3 and it would be 3 square root of 3. And so your rectangular form would be 3 square root of 3 plus 3i. Okay. So this is the rectangular form. Okay, let's go to number 18. You have z1 equal to 3e to the 97 degree I. z2 equal to 5e to the 68 degree I. And they want you to find z1 times z2 and z1 divided by z2. So let's go and do the multiplication first. So z1 times z2, you just multiply 3 times 5 is 15. And when you multiply, you add the exponents. And so you get 165 degree I. Okay. When you do the division, you just divide, so you get 3 over 5. And then you subtract the exponents as the degree. So you get 29 degree I. Okay, and that's it for number 18. Okay, let's go to 24. You have negative 1 plus I times 1 plus I. Okay, for this one, it says find each one found by multiply directly and by using the Porter form. Okay, so we're not going to do the multiply directly. Multiply directly means just going to use the FOIL method and multiply out. Okay. Now, when the exponent is kind of low, like this one, only the exponent 1, so it's quicker if you just do the regular multiplication. But when the exponent is like really high, like 13 or like 7, then you want to use a convert to Porter form and multiply in Porter form. That's much easier to do. Okay, so let's go and do some of these. So this one, you get negative 1, 1. So this one will give you square root of 2 e to the 135 degrees I. This one is 1, 1. So this one will be square root of 2 e to the 45 degree I. So when you multiply this will give you 2. When you multiply this, you add, you get 180 degrees I. Again, I just part of the form. So if they want you to put in the Porter form, and that's it. Okay, so this would be the Porter form. Now for the rectangular form, you draw this over here. Okay, so r equal to 2. And in this case, the coordinate over here, this would be negative 2, 0, right? So in this case, the rectangular form would be negative 2 plus 0i. Okay, but you don't have to write 0i, right? So it would be just negative 2. Okay. Let's go to 26. Yeah, negative 1 plus I squared. Again, I'm not going to multiply using the rectangular form. It's just a regular multiplication. So I want to do it in the Porter form. So you can negative 1, 1. So this is same as last one. So you get square root of 2 e to the 135 degrees I. And this is a square, so that's a square. So when you multiply out, when you square, you get 2. And this one you multiply, you get 270 degrees I. And so this will be your answer in the Porter form. For the rectangular form answer, you sketch it out. So 270 degrees right over here, and r equal to 2. But looking at that in the rectangular form, this will give you 0 plus 0 minus 2i. Right? It's negative. So 0 minus 2i, and therefore you don't write 0, right? So answer will be just minus 2i. Okay, let's go to the next one. Let's go to page 433. And let's do number 6. So you got 1 plus square root of 3i to the 3 power. And they want you to find the value using the Moivre theorem. That means you have to use the Porter form. So sketch it out. So you got 1 square root of 3. So 1 square root of 3. So convert this into Porter form. You get 2 e to the, so this is 60 degrees to the 3 power. So when you multiply out, 2 to the 3 power is 8. And when you have exponent of the exponent, you multiply. And they want you to leave the answer in the Porter form. And so that's it. Okay, let's go to number 10. Yeah, 1 minus I to the 8th power. So you want to find the value, so you want to work it out, and you want to put answer in the rectangular form. Okay, so you got 1 minus I, so 1 minus 1, so this will be square root of 2. This becomes square root of 2 e to the negative 45 degrees I to the 8th power. So this is when you to the 8th power, right? Square root of 2 is equal to 2 to the 1/2 power. And when you raise to the 8th power, this will equal to 2 to the 4. Okay. So when you raise this to the 8th power, it becomes 2 to the 4, so it gives you 16. And when you multiply this out, you get negative 360 degrees I. And to convert this into the rectangular form, again, you can draw your triangle very quick. Now, negative 360 degrees would be right over here, right? Because you're going backward, and so it would be 16. So rectangular form would be just 16. It would be 16 plus 0i, but you don't write the 0i, right? And so that's it. Okay, let's go to 16. You got z equal to 27 e to the 120 degree I, and n equal to 3. So n equal to 3 means you're looking for the cube root. Okay. So z to the 1/3 power will equal to 27 e to the 120 degree I to the 1/3 power. Again, n equal to 3 means you're looking for 1/3 power. And you're going to get 3 answers. So first answer, okay, 3rd power, the cube root, you get 3. And this one you multiply, you get 40 degrees I. Since there are 3 answers, each one will be 120 degrees apart, right? 360 degrees divided by 3 answers, you get 120. So W2, W3, again, the length does not change. So it would be 120 degrees, so you add 120, you get 160 degree I. At 120, you get 280 degrees I. Okay. And so this would be your 3 answers. Okay, let's go to 24. You get z equal to I and n equal to 6. So if you sketch it out, so this is 1, so it's right over here. Okay, so this is 1i. So in this case, z equal to 1 e to the 90 degree I. And n equal to 6, so z to the 1/6 power is equal to 1 e to the 90 degree I to the 1/6. So W1, so there will be 6 answers. W1, 2, 3, 4, 5, 6. So first one, you take that, so you get, and you don't have to write 1 if you don't want to. So it would be just e to the, so 1/6 would be 15 degree I. So that's the first one. Now there are 6 answers. So since there are 6 answers, 360 divided by 6 equal to 60 degrees. So each one would be 60 degrees apart. So next one would be 75 degree I. You add 60, so e to the 135 degree I. Add 60, you get e to the 195 degree I. Add 60, so it would be 255 degree I. Add another 60, so e to the 315 degree I. And so this would be your answers. Okay, let's go to 28. You're solving the equation. So you got x cubed minus 27 equal to 0. So what you want to do is go and solve for one of the answer. So plus 27 on each side. You get x cubed equal to 27. You take the cube root, so x equal to 3. So, and this would be your first answer. So x equal to 3 is right over here, and if you draw a circle, okay, so this is your x1, and the other 2 answers would be spread out evenly, 120 degrees apart. So this is equal to 3, so this would be 3, negative 3 over 2, and this would be 3 square root of 3 over 2. That's your spatial triangle. This would be negative 3 square root of 3 over 2. So x2, so this is your x2, this is your x3. Again, you can use different variables if you want to, but since this is x, so just use x1, x2, x3. So next answer would be negative 3 over 2, so this one here, plus 3 square root of 3 over 2i. This one over here, you have to go this way and down, so negative 3 over 2 minus 3 square root of 3 over 2i. By the way, if you add all those answers in a circle, it will always come out equal to 0. So if you add all this together, it will equal to 0. Same thing this one over here. If you add all the 6 answers together, you will end up with a 0. Because what happens is they all cancel out into a single point, so it becomes 0. Okay, let's go to number 30. You got x cubed plus 64 equal to 0. So minus 64 on each side. You got x cubed equal to negative 64. Take the cube root, so x1 equal to negative 4. Again, if you sketch it out, negative 4 is over here. And again, if you draw the circle, so this is the first answer. So the other two answers would be over here. So this is your x1, x2, x3. And this is the x equal to negative 4, but the r equal to positive 4. So make sure you make the distinction between that. Okay. So this would be a 4, 4. So this would be 2. It's 2 squared root of 3. 2 squared root of 3, negative. So x2 would be 2 minus 2 squared root of 3i. Now don't forget your I. I tell you that this is a complex number and you go in the I direction. x3 would be 2 plus 2 squared root of 3i. And that would be your answer. Again, you can check your answer very quickly. When you add all this together, it will always end equal to 0. See, this will cancel out. 2 plus 2 is 4, minus 4, it gives you 0. So when you add all the answers together, it should be equal to 0. Okay. And so that concludes our review.